Today we're going to talk about equivalent rules for sequences. Here we have 3 different stages of a sequence. Stage 1 has, it has 6 toothpicks. Stage 2 has 8 toothpicks. And stage 3 has 10 toothpicks. Now, if you'll notice, regardless of the stage, every one of these have 2 toothpicks on the left and 2 toothpicks on the right. So regardless of the stage, there are always 4 toothpicks in the total number. So we're trying to come up with a rule to describe this sequence. So the number of toothpicks is always going to have 4 toothpicks added. Once we've figured out how many toothpicks are in each stage, we're always going to add 4 for the ends of each of the stages. Well, stage 1 has a toothpick at the top and a toothpick at the bottom. 1 toothpick at the top, 1 toothpick at the bottom. So that sounds like it's 2 times stage 1. And again, we will let n represent the stage. Let's see if that works in stage 2. Stage 2 has 2 toothpicks at the top, 2 toothpicks at the bottom. 2 times 2. Yes, if n is the stage, 2 times 2 toothpicks plus the 4 on the end. 2 times 2 would be 4. 4 plus 4 is 8, and that works for stage 2. Let's see if it works for stage 3. There are 3 toothpicks at the top and 3 toothpicks at the bottom. So it's 2 times the stage number, 3. 2 times 3 plus the 4 that left and the right ends. 2 times 3 is 6 plus 4 is 10. Yes, so this rule seems to be working for these stages. But my question is, would there be another rule that might possibly also describe this sequence? I've drawn the same sequence again with stages 1, 2, 3, but this time, instead of setting it up the way I did the first time, let's imagine cutting each stage in half. Now, stage 1 has 1 toothpick plus 2, 1 on the left, 1 on the right. So there's 1 toothpick plus 2, and there's a top and a bottom. There are 2 of those. So this could describe our rule for the number of toothpicks. Let's see if it works for the second stage. This is stage 2 plus the 2 toothpicks, 1 on the left, 1 on the right, and there are 2 of those, a top and a bottom. Okay, and then let's try it for stage 3. There are 3 toothpicks plus the 2, 1 on the left, 1 on the right, and there are 2 sets of these. 1 above the red line, 1 below the red line. Okay, let's see how many total toothpicks we get here. 1 plus 2 is 3. 3 times 2 is 6. Yes, there were 6 toothpicks in the first stage. The next one, 2 plus 2 is 4. 2 times 4 is 8. Yes, there were 8 toothpicks in stage 2. The last one, 3 plus 2 is 5. 2 times 5 is 10. Yes, there were 10 toothpicks in stage 3. So how do we write this like a rule? This is stage 1, stage 2, stage 3. So if we let n represent the stage number, there are 2 sets, a set above the red line, a set below the red line, that uses the stage number plus 2 toothpicks, the ones that are on the left and the right. So this is also a rule that works for this exact same pattern. Here's another sequence to consider. I've shown the first 3 stages. This one is very easy to think of grouping into 2 sections. Like this is a group and this is a group, just like this is a group and on the right is a group, and etc., etc. So for stage 1, this would be 1 toothpick plus another, and then I've got two sets of those, one on the left, one on the right. Here I've got stage 2 plus one more toothpick in my red circle, and there are two circles, two groups of that. Here again, if I wanted to go back to my circles, let's see here. I've got stage 3. I've got 3 toothpicks in my left circle plus one more toothpick, and I've got two circles, two groups of that. So if n represents the stage number, we could write the rule for the number of toothpicks as 2 times the stage number plus 1 will give you the number of toothpicks. And it definitely works. When we check up here, 1 plus 1 is 2, 2 times 2 is 4. There are 4 toothpicks in stage 1. 2 plus 1 is 3, 3 times 2 is 6. There are 6 toothpicks in stage 3. 3 plus 1 is 4, 2 times 4 is 8. There are 8 toothpicks in stage 3. Another way to describe this sequence is that since this is stage 1, you could say, well, there are two ones. So 2 times stage 1, or 2 times n, plus you still have 2 more toothpicks, so plus 2. Let's see if that works over here. 2 times stage 2, all right, so I've got, this time I've got 2 of these, stage 2, 2 of these, 2 times 2, plus I've got the 2 legs hanging down also again. This time, 2 times 3, okay, I've got 3, this is stage 3, 2 times stage 3, plus I've still got my 2 more. So that is another rule for describing this set. 2 times the stage number plus 2 more. So there are sometimes multiple rules for describing the same set.